All right, so when you solve the Schrodinger equation, you're going to get out a set of orbitals and their energies. And I said that those orbitals are basically shapes, balloon animals and whatnot. Here we go. These are those shapes. All right, so remember the L values. I said the L values designate the shape. So the angular momentum quantum number, that second quantum number. So when L equals 0, that's an S orbital. And L equals 1, it's P. 2 is a D. 3 is an F. All right, but in S, it's a sphere. So all S orbitals are kind of like a ball. So that first little psi squared plot that I showed you, like that scatter plot that looked like a shotgun splatter, that's an S orbital. So we usually just draw them like a kind of a solid shape, but really it's more of a fuzzy thing with an ambiguous edge to it. But this is what we use to represent an S orbital. A P orbital looks like a peanut, and then a D orbital. This one looks like it got hit by a truck or something, but it's a double peanut. I like calling it a double peanut instead of like a clover because it kind of looks like a clover, but I like this alliterative thing I have going on here. So S, sphere, P, peanut, D, double peanut, and F, that's a funky peanut or a flower or something crazy. I'll show you one of those a little bit later on in here. So let's talk about the S orbitals. So an S orbital, that's when you have an L value of 0. There's an S orbital on every energy level of the atom. So the very first energy level, when n equals 1, right, L can only be 0. So that's actually the only thing that's on that first energy level is this 1s orbital, and it's shaped like a sphere. So here's a 1s, here's a 2s, here's a 3s. Like, what's the same? What's the difference? Well, they're all spheres, so that part's the same. The difference is they get bigger and bigger and bigger. All right, so an electron that's in the 3s is going to spend more time farther away from the nucleus, so it's going to be at higher energy. Remember, the closer those electrons get to the nucleus, the lower their energy, the happier they are. So this is like primo. This is where all the electrons want to go. They would love to be in this 1s orbital because that's the one that's sitting right next to the nucleus. All right, but as you go up to higher and higher energy levels, right, these get bigger and bigger. All right, let's go on to the p orbitals. All right. The L value for a p orbital is going to be 1. You do not see the p orbitals until you hit the second energy level, right? You have to have L equals 1, right? That's not possible on the very first energy level. Remember, the values for L, they start at 0 and they go up to 1 less than n. So n has to be 2 or greater for you to see a p orbital. Now, the p orbitals look like a peanut, and there's different orientations of the peanut, right? So here's the actual function there, but we draw them like this. So this looks like a peanut. So this points along the z-axis, so we call it pz. This one's along the x-axis, px, and this is py. They are, the fancy word is, or the fancy phrase is, they are mutually orthogonal. That just means they're all perpendicular to each other. All right, but this corresponds to if our L is 1, m sub L could be -1, 0, plus 1. That corresponds to these 3 different orientations of the p orbitals. All right, let's go on to the d orbitals. The d orbitals do not show up until the 3rd energy level. So there's no d orbitals on the 1st level, no d orbitals on the 2nd level, but on the 3rd level and higher, we have d orbitals. All right, that's because the L value for a d orbital is 2. All right, so you have to have an n equals 3 or greater to see the d orbitals. Now, if L equals 2, m sub L would be -2, -1, 0, 1, 2. Right, there's 5 m sub L values. There's 5 d orbitals. That's how these things connect with each other. And the last one I'll show you would be the f orbitals. All right, f orbitals, when you have L equals 3, that's f orbitals. The f orbitals don't show up until that 4th energy level. All right, so the 4th energy level, that's where you first see the f orbitals make an appearance, and they'll be on everything past that. But if L equals 3, so get your hands out and start counting, right? The m sub L values, -3, -2, -1, 0, 1, 2, 3. That's 7. There's 7 values of m sub L. Count these. There's 7. Right, that's the orbitals. All right, let's go to this. This looks a little crazy, but we'll break it into little bite-sized chunks. So normally in class, I kind of like just drive this on the board and we build it up. And it's already right here, so let's just work with it. So if n equals 1, L can be only 0. So it always starts at 0 and goes to 1 less than n. So when n equals 1, L can only be 0. When n is 2, L can be 0 or 1. When n is 3, L could be 0, 1, or 2. When n equals 4, L is 0, 1, 2, 3, right? So that's an easy pattern. So hopefully you guys are like catching on to that, and that's cool. Now let's look at m sub L and L. When L equals 0, m sub L can only be 0. Right? Here's another one. L equals 0, m sub L can only be 0. When L is 1, m sub L goes from, remember, it goes from negative L all the way to positive L in integers. So when L equals 1, m sub L could be minus 1, 0, plus 1. Right? So when it's 0, it's 0. When it's 1, minus 1, 0, plus 1. When L equals 2, your m sub L values go from minus 2, minus 1, 0, 1, 2. Right? And let's just kind of jump down here. So when L equals 3, right, your m sub L's could be minus 3, minus 2, minus 1, 0, 1, 2, or 3. These correspond to different orbitals, right? So this, when m sub L is 0, that's an s, right? And when it's on the first energy level, that's a 1s orbital, right? This would be a 2s orbital. And then these are the 2p orbitals. Right? Remember, there's 3 orientations. Remember the peanut? There's one up and one there's px, py, pz. Let's just put it that way. I was going to say up, down, left, and right, but that would be 4. So never mind. So x, y, and z, right? So minus 1, 0, plus 1. That's what we have there. But each one of these things is an orbital. So this is an orbital. This is a p orbital. This is a different p orbital. This is the other p orbital. So every p subshell, right? So remember, like all these things, all these things with the same value of n form a shell, right? So all these things make a shell, like all together, this is a shell. But each of these guys with the same orbital types. So the 3s would be a subshell, a 3p subshell, 3d subshell. These are all the orbitals. So every p subshell has 3 orbitals. So it doesn't matter if it's a 2p or a 3p or a 4p or a 5p or a 6p. The p subshell is always made up of 3 orbitals. So you have the px, the py, the pz. Same thing when you get to d. Like d always has 5 different values, right? The 3d, so that's the first place you see the d orbitals pop up, is on that third energy level, right? You have minus 2, minus 1, 0, 1, 2. Those are the orbitals. These are the different clouds. Remember I showed you the picture of those different double peanuts? There was 5 different clouds, right? These are those 5 different clouds. Each one of these clouds actually holds 2 electrons. So each cloud can only hold 2 electrons. I'll get to why that is in a later video in this chapter, but each cloud only holds 2 electrons. So remember the slide I showed you guys a little bit earlier where I told you how to calculate how many electrons can fit into an energy level, right? And I said it was 2n squared. That still is absolutely true. When n equals 1, there's 2 electrons. When n equals 2, 8 electrons. N equals 3, 18. N equals 4, that's 13. But now we know a little bit more, right? Because the first energy level is just made up of 1 sublevel. The second energy level has 2 sublevels. The third has 3. The fourth has 4. Nice pattern there going on. But the very first energy level is just an s orbital. It holds 2 electrons. The second energy, s and p, there's your 8. Remember, there's 2 in the s, and there's 3 different p orbitals, right? There's 3 p orbitals. Each one holds 2. So that gives you the 6. We get to that third energy level. That's s, p, and d orbitals, right? There's 1 s orbital, 3 p orbitals, and then there's 5 d orbitals. So each one of those orbitals holds 2 electrons, bam, 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 and so on. So all this adds up. So this is just like a better level of understanding and a little bit more detail that we understand about where the electrons are in the atoms. All right. 1 or 2 more lectures in this chapter. It's a beefy chapter, but we'll make it through. All right, see you in the next one.